I'm very happy to be here today to talk about one of my favorite parks and one of my favorite subjects, which is a project I've been working on for the last 5 years since I started with state parks. And it's a tidal flow restoration project within Sunken Meadow Creek and Sunken Meadow State Park. Before I get into that, I just wanted to give a little bit of background about state parks in general. For the Long Island region, we have about 32 state parks and sites. And of them, roughly 20 of them are coastal parks. So if you look at the map, you can see where all the state parks are located. I hope any Long Islander has been there and you know what I'm talking about. And if you haven't been to any of these parks, I highly encourage you to go to them because they're all fantastic. The 20 parks that are coastal help protect our shoreline, which is very important, in addition to their importance of providing recreation for our patrons. And the rest of the parks are all interior, and they protect all of our interior upland habitats. A year ago, we know what Superstorm Sandy did all over Long Island, everywhere. Within the state park system itself, it affected every single one of our parks on Long Island. You can see by these pictures some of the damage that occurred in our different parks. Even our interior parks, we lost a lot of trees. We had a lot of damage along some of our coastal areas. We had flooding, we had infrastructure damage, we had all sorts of road damage and different things. Some of our parks were closed for a long time, but our park staff worked very hard to try to open the parks as soon as possible, to try to provide a haven area for people to be able to return to nice areas to visit when they're going through such devastation. It's been estimated within the park system that it would cost over $100 million in damage just to the state parks themselves. But I'm here today to talk about Sunken Meadow State Park. And like I said before, it's one of my favorite state parks. I say that about most of my parks, but it really is. Sunken Meadow was established in 1926. And at that time, it was a very small park. We only had a couple hundred acres. And since then, we've acquired much more. So now it's over 1,200 acres in size. Sunken Meadow State Park is located along, oops, where's cancel? There, got it, thank you. It's located along the North Shore, along the Long Island Sound, and right near the mouth of the Nisqually River. It has almost 3 miles of shoreline, and it supports about 2.5 million visitors annually to it. So it's a very important park recreationally, and it also is very important for ecological reasons as well. It has very diverse habitats, it has endangered species, and many things there. So because of that, it is part of the Long Island Sound Stewardship Site. It is part of the Nisqually River Stewardship Area, just because of the ecological and recreational importance. So I wanted to show you a little bit about the history of the park and how it's evolved over time and what the changes have been. This is an aerial photo from 1930. And if you look, you can see how sinuous the creek was at that time and very undeveloped. We had just acquired the park 4 years before this photo was taken. We had started to put in some areas where people could come to park, but in general, it was untouched. The western part here, we had extensive tidal wetlands that went all the way almost up to the Sound, and there was a breach where the water flowed straight into the Long Island Sound, and also at the eastern end where it flowed into the Nisqually River. Then in the 1950s, Sunken Meadow was immediately a very popular park, and it was hard to keep up with the demand for public access to the park. So we started adding a lot of infrastructure in the 1950s. This is 1953, so it's just before more of the Sunken Meadow Parkway opened. And we had already started to add more infrastructure into the park, trying to add more areas. So some of the wetlands were starting to be filled, but not a lot yet, and the creek was still very sinuous all throughout. Then around 1957, the Sunken Meadow Parkway opened, and and it opened a whole channel for people to be able to come to our park, and the visitors flooded it. And we had over 1 million visitors a year, and we couldn't keep up with the park infrastructure. We needed to add a lot more, so they added in more parking fields. And we have more on the north side of the creek and on the south side of the creek. And it's stayed that way since then. This is an aerial photo from 2004, and so for the last 60 years, this is the way that the park has been. If you look at the parking fields, you can see some of them still remain a little wet, and this is where it used to be the tidal wetland, and it still tries to remain wet that way. What they did at the same time around when the Sunken Meadow Parkway opened, and they were trying to create more parking fields, they straightened and dredged Sunken Meadow Creek. So it's no longer sinuous, and the breach used to come out through where parking field 3 is now, and all of that was filled in. There was a berm that was put in on the eastern end of the creek right here. That was an earthen berm with 2 small culverts, and that restricted the tidal flow between the western tidal marsh wetlands and the eastern, and so the western area became much more fresh. This is a picture from when the construction took place in 1957. You can see they cleared the whole area. They put in these 2 small culverts, and that's all the drainage we had. The only way that we could have any tidal exchange between the salt marsh to the east and the wetlands to the west. And keep an eye on this rock. This is going to be in a lot of pictures. It's a good landmark to keep an eye on things. And this is Sunken Meadow a year ago, before Sandy. You can see it's grown up with vegetation all around it. We do have some natives, but we do have a lot of invasive plants in that area. And the arrow is where the berm is and the small culverts. And the water was very slow, stagnant, and not moving. There's not a lot of tidal exchange between it. Here's another view of the creek. You can see how it's all straightened. There's the rock that we always keep an eye on. You can see how cleared out everything was at the time. The other thing you can see is just how full our parking lots were and our beach. They were constantly full. The parkway going out of the park would be full of cars. It was just such a popular area, and still is. So when the berm was put in, it disrupted the natural processes of the tidal marsh, and it allowed very little tidal exchange between the salt marsh to the east and the wetlands to the west. This resulted in the creek having very low salinity and supporting a lot more freshwater species that normally wouldn't have been there. And it also allowed invasive Phragmites to come in. And we have acres and acres of it. You can see how lush it is on the bottom in some of the western wetlands. It was very tall, very vigorous, huge mats of it. And also, it had poor water quality. Because the water was so stagnant, it wasn't flushing. It would have low dissolved oxygen. It would have high fecal coliform oftentimes. And also, the culverts that were put in were 60 years old, and they were degrading. So they're falling in on themselves. They would frequently get clogged with vegetation or rocks, or fishermen would put rocks into the culverts to try to have a better fishing area there. And so they were going to fail, and then we wouldn't have any tidal exchange at all. So we needed to do something. And what we wanted to do was restore the tidal flow. We knew we couldn't get it back to how it originally was, such a natural system, but we wanted to try to get it as close to that as possible. So our goal was to increase the tidal flow into the creek, and by doing that, help to restore the degraded salt marsh upstream. We also, by opening it up, it would enhance the fish passage. We did have some fish passage before then, but the small culverts really prevented much of an exchange with the fish. And when they were in the salt marsh trying to move upstream, they would only be able to at very high tide because the culverts were set at such a high elevation. They would only be flooded at very high tide. And with the increased salinity, by restoring the tidal flow, we were hoping that would help limit some of that Phragmites and encourage some of the remnant salt marsh species, the native salt marsh species that were hanging on. We had some areas where we had Spartina and some other native vegetation still holding on in little areas, little patches, and we were hoping once the tidal flow restored, they would expand. And at the same time, we didn't want to negatively affect our infrastructure or the neighbors that lived right along our creek. We didn't want to flood them out either. So what we had to do was have a feasibility study that we hired contractors for to try to model for us different possibilities of what we could do in order to restore the tidal flow, and what would be the best alternative. What could we do? Would we need some sort of water control? Would we be able to open it up? We didn't know how much we would actually be able to open the creek and restore the tidal flow. But we were talking about restoring tidal flow to about 132 acres of marsh, which for the Long Island Sound area is considered a large-scale coastal restoration project. So NOAA listed it as a priority project for the Northeast, and it has been an important project for us to get moving along. The consultants with their feasibility study did a lot of modeling. We've also been collecting pre-monitoring data for a long time, and what they found was that we would be able to open up the creek completely and put a bridge over the what was currently the berm area, and open up tidal flow completely and be able to have tidal exchange without worry of flooding our infrastructure or the neighbors. We have been collecting pre-monitoring data since I started in 2008. I've been lucky enough to work with a bunch of school groups and a lot of professionals, of which a bunch are here today, I know. And we've been collecting data such as water quality, macroinvertebrates, fish, all different things that we've been able to look at the creek. And we were very lucky to have about 5 years of pre-monitoring data. Just before Sandy hit, at the time of Superstorm Sandy, we were completing an engineering design for installing the bridge in the park. The consultants were about at 90% completion of the engineering design, and then the next step would be for us to find funding. And that was where our question was, how are we going to fund this project? We have the idea of what we need to do and how we can do it, but how can we fund it? Because it was extremely expensive, and we didn't know where that was going to come from. So we were trying to research grants and other ways to try to get this project moving forward. And then bam, Superstorm Sandy hit. And it pretty much looked like it exploded the berm. I don't know how easy it is for you guys to see, but here you can see sand fans going each direction, east and west, out of the berm area, and it's completely breached. And there's the little rock that we keep an eye on. So it separated the north and the south end of the park. It was a popular, or is a popular trail, a popular cross-country trail, and it disrupted the access that way. But it opened up and pretty much did my project for me. So that was our way of getting funding. Superstorm Sandy did this for us. So the red arrow shows where the breach was in the berm. And we have new aerial photos since then. The aerial photos taken show that we now have tidal flow and we now have low tide. We never had a tide before. The water, we had used data loggers to try to show how the tide would change within the creek compared to the salt marsh, and there was such little tidal change before the storm. But now we have low tide, and it created mudflats. And so now we have all these mudflat areas within the creek that we never had previously. And the overall picture of the creek, we have more extensive mudflats all throughout this area during low tide. And the current high tide, when we have high tide come in, is about the same level that it was always kept at previously. So now we have 4 pictures that show the changes of how the creek has changed over the last long time. So I wanted to show you what have we seen since then. What has changed since Sandy came and blew out the berm. This is what the berm looks like on the ground. Pre-Sandy to the left, it was an earthen berm, and it had a trail going over it, and there's a lot of rocks. and the 2 small culverts. Post-Sandy, you can see the culverts were broken all apart and just in the creek. The rocks were blown everywhere, and the tide could come in and out as it will. Since that time, we have done work on the creek, and the culverts are no longer there. So what was State Parks' response? Luckily, we had done the feasibility study, and we had done the engineering design nearly to completion. So all we needed to do was modify the engineering design. And as a result, we were able to do that and have a bridge installed, and it was installed this last October. We have the bridge in, and it is now open, and you can access the park. We are very lucky that this happened. We don't know how we would have reacted otherwise if we didn't have the modeling done beforehand to know that we wouldn't flood ourselves and we wouldn't flood our neighbors. How much of a knee-jerk reaction would we have had to do in this area if we hadn't already done all this work beforehand? And this is just another view of the bridge, brand new when it was going in. So as we move up the creek, which was tidally restricted before, we can see all the changes that have been happening in the last year. So pre-Sandy, this little rock, which we call Cormorant Rock, was always flooded to this level. There was very little of that rock exposed whenever you went there. And the water was always at a high level. And you can see there's Phragmites all along the creek channel itself. After Sandy, we have low tide, and you can see how much exposed the rock is at low tide now. And you can see sand and rocks coming in and erosion along the edges of the creek. The most recent photo I have is on the bottom, and you can see there's still changes going on within the creek, and there's erosion along the shorelines. And every time we go there, we take pictures because it's so dynamic, and it changes every time. Every time I go, it looks different. So I always have to have pictures of what's going on at the creek. We also have a new view from the pedestrian bridge. When we go out on the bridge and look out, previously before Sandy, there was this big, healthy mat of Phragmites and this little basin here that was always full of water. And post-Sandy, we now have mudflats. And this is one of the areas we're hoping to do some Spartina restoration in that area. We have much more mudflats that have been created. When you look at the western wetlands that were so extensive, tidal marsh wetlands previously, you could see what it looked like to the left. Before Sandy, it was always inundated, open water, and then you'd get to the dense Phragmites areas. Now at low tide, we have extensive mudflats that are now visible. And the water quality. One of the instant things that we saw was the flushing of the creek. That never happened before. So pre-Sandy, the water would be very stagnant, very green or brown, and you couldn't see in it, you couldn't see down into it. And now, after the storm, because of all the flushing, it's very clear. You can see everything in it. You can see animals moving below you very easily. And also, obviously, the change in salinity. Now that we have tidal flow, the bottom line there, you can see that's what the salinity was pre-Sandy. So the dotted line going up is where the culverts were. And to the right of them is the salt marsh area where we have higher salinities. And then as soon as you get past the culverts to the left, going westward, where it was restricted, we have very low salinity pre-Sandy. After Sandy hit, our salinity increased dramatically all the way up to the weirs, which are very far west, up into the wetlands. So that was an instant change. So what were some of the changes to the flora? One of the big ones was Phragmites, and this is the one I was waiting for. But pre-Sandy, like I said, we had such dense, thick, tall Phragmites. Afterwards, this is a canoe trip we did a month or so ago up in the wetlands, and you could see the Phragmites is much less dense. In a lot of areas, it's dead, including the view from the Pedestrian Bridge. This is what it looked like from the Pedestrian Bridge in August, which I thought was the coolest thing in the whole wide world. When you look out, you can see the Phragmites is all brown and dead. There is a little bit of patches of living Phragmites along the shoreline, which is expected, and everything else is green, which is wonderful. So the Phragmites does not like the high salinity, and it's dying back. And this is the view of the western wetlands, too. We have even more extensive areas of dead frag or stunted frag. And this is a view here. You can see even where it is growing, it's not happy. It might be hard to see, but there's tall stalks from last year that have old seed heads on them. And you can see just how tall the Phragmites was last year before the storm hit. And now it is half as tall or less in the areas where it does want to grow. And in most of those areas, it didn't go to seed this year. And at the same time, we have a lot of natives that are, the natives that were hanging on in there are popping up and coming back in. If you look at the front here of this mass, this is all natives coming in. We have Spartina alterniflora and patens and disticulus all growing in these areas, coming up where the Phragmites is dying or dead. They're coming up in those Phragmites islands. The back here, that is Phragmites growing along the shoreline. So these are some of the natives that we see here. Where the Phragmites islands are, that the frag was dying off, we have natives coming in, and even Spartina alterniflora looking tall and going to seed, which is very happy. We were very happy to see that. And Salicornia, we had Salicornia coming in up the creek channel and growing all along the edges of the creek. And this also shows how the Phragmites is being affected. This is a mass of Phragmites, and you can see the erosion, how big mats of Phragmites have broken off, and just how much we've lost. We've seen a lot of Phragmites break off in chunks and float down the creek, and we've lost a lot of Phragmites this way, where it's just gone out of the marsh. But the Salicornia is coming in where it's left off. And for the fauna, some of the changes we've had with the fauna, what looks like black rock here in front of Cormorant Rock is actually a big colony of blue mussels that have come in there. That is very different than what was there before. That wasn't possible before. Now that we have low tide, we have them coming in there. And a bunch of other macroinvertebrates. Before the storm, we did find crabs occasionally up the stream. We'd have green crabs or blue crabs once in a while, but not to the number that we're seeing now. We'd also always, when we seined, we always would catch little shrimp, and we continue to do that. But now, after the breach, and now that it's opened up, we're seeing a lot more, like we're catching many hermit crabs, many horseshoe crabs. There's mud snails galore all throughout the creek bottom. And we're even seeing other cool things like jellyfish, comb jellies, and lion's mane jellies and stuff upstream, which is very, very awesome. And for the fish, we've been looking at the fish for the last 5 years as much as we can. We've been doing a lot of seining. We used hoop nets and minnow traps and dip nets. And we've also go out with DEC when we can and do fyke netting in the creek to try to catch some of the bigger fish. Now, unfortunately, this year we tried, but we weren't able to make it work out with setting fyke nets in the creek. It's a lot more complicated now that we have the tides and we have such low tide. We have to make sure we're okay when we set the nets, and it just hasn't worked out. But we're hoping that next year we'll be able to do a lot more fish sampling with DEC and get a more complete picture. But we do have some data of what we've caught so far and some of the changes. Now, when we did our fish sampling, we sampled within the creek and also within the salt marsh outside the creek to try to be able to compare the differences of what was found when it was restricted to when it was a salt marsh. And then this This table here is showing Sunken Meadow Creek itself when it was tidally restricted compared to now that it's open and what we're seeing. So some of the important species, some of the species that we've been sampling, we were fortunate enough to do our last fish sampling before Sandy, about 2 weeks before Sandy hit. We had a school group out and we were seining. And the dominant fish that we caught in our seines was pumpkin seed sunfish. And we caught hundreds and hundreds and hundreds of them at the time. We went out as soon as we could after the storm, and we haven't caught a single pumpkin seed since, which makes sense because of the high salinity. We wouldn't be expecting that there. Because everything was so raw and changing and everything after the storm, our early surveys of the fish mostly just caught big schools of Atlantic silversides, which we had caught up the creek previously. We've always caught silversides there. But that was the main one. We didn't catch the diversity at first of what we had been getting pre-Sandy. During spawning season, alewives came in. It was much easier for them to come in now. We have had alewives spawning within the creek prior to Sandy, but it was much more difficult for them to get in through the small culverts. But they did spawn within the creek where it was much more freshwater area. Now they can easily move through it, but their freshwater spawning habitat is very restricted now to all the way upstream. We have some fish weirs and some freshwater fish ponds way in the western part of the wetland. And one of our priority projects is to enhance fish passage to those ponds to provide more spawning habitat for the alewives, because it's very important to us to try to help them as best we can. And since the storm happened, we started catching things that we used to catch in the salt marsh and not so much up in the creek, such as striped killifish. Prior to the breach, we mostly just caught banded killifish. Now we're getting a lot of striped. And the students were always really excited because